Electric isn't the only alternative to the traditional gasoline or diesel-powered car. There are also hydrogen fuel cell car options, such as the Mirai, a hydrogen fuel cell car from Toyota. In those vehicles, compressed hydrogen is used in conjunction with a catalytic fuel cell membrane to generate the electricity to drive the vehicle. Cars using the technology can have a 300-mile range, with fuel ups taking as little as 5 minutes. Amazon CEO Jeff Bezos established the Amazon Climate Pledge to support the development of sustainable technologies so Amazon and other companies can achieve net zero carbon emissions by 2040, 10 years ahead of the Paris Climate Agreement. The funding will be used for the ongoing development of the startup's ZA600 hydrogen fuel cell powertrain. Toyota started working on the development of fuel cell vehicles where hydrogen from a tank mixes with oxygen producing electricity back in 1992. In 2014, it launched the Mirai, a hydrogen fuel cell sedan. Alongside Mirai, Toyota has had a hand in the development of larger hydrogen fuel cell vehicles. These include a bus called the Sora and prototypes of heavy-duty trucks. As well as fuel cells, Toyota is also looking at using hydrogen in internal combustion engines. The use of hydrogen is going to be an important factor in achieving carbon neutrality. Yoshikazu Tanaka, Mirai's chief engineer, said. Hydrogen backers said, "It's cleaner than other carbon-cutting technologies because water and heat are the only byproducts and they can be made from sources, including methane, coal, water, and even garbage." Resource Port Japan also sees it as a route to energy security. Instead of being powered by electricity stored in a battery, hydrogen fuel cell electric vehicles produce their electricity through a chemical reaction between hydrogen and oxygen in a fuel cell tank. A fuel cell is a device that takes chemical energy in the form of hydrogen and turns it into electricity that can power an electric motor, just like a battery. First, hydrogen stored in a tank that is thick-walled and crash-tested and usually under the rear seat is mixed with air and pumped into the fuel cell. Inside the cell, a chemical reaction extracts electrons from the hydrogen. The leftover hydrogen protons move across the cell and combine with oxygen from the air to produce water. Meanwhile, the electrons create electricity, which charges a small storage battery used to power an electric drivetrain, just like in an electric vehicle. A fuel cell contains an anode, a cathode, and an electrolyte membrane. It creates an electric current by passing hydrogen through the anode and oxygen through the cathode. At the anode, a catalyst splits the hydrogen molecules into electrons and protons. At the cathode, the electrons are reunited with the protons and oxygen to produce water, and FCEV's only tailpipe emission. A fuel cell's efficiency, the amount of energy extracted from the fuel, is about 90%. However, in a vehicle, it's tough to make use of all of the fuel cell's efficiency. Approximately half of the energy the fuel cell releases is low-temperature heat, which in a passenger car is challenging to make use of this low-grade heat reliably. Therefore, in a passenger car, a fuel cell's working efficiency is closer to 45% when powering an electric motor. As in a petrol-electric hybrid, the electricity is boosted in voltage to drive the electric motor. Further energy is captured in a battery every time the car brakes or slows down, which contributes to even better fuel economy. Once filled with hydrogen, fuel cell vehicles use reverse electrolysis, where hydrogen reacts with oxygen taken from ambient air in the fuel cell. However, these batteries are much smaller and therefore lighter than the batteries used by plug-in electric vehicles. Like plug-in vehicles and hybrids, fuel cell cars can create electricity by harvesting kinetic energy lost during braking and coasting, then feeding it back into the battery. Fuel cells are not only more reliable due to a lack of moving parts, but they're more efficient too. This greater efficiency is because the chemical potential energy is converted directly into electrical energy rather than having to first be converted into heat and then again for the mechanical work, which is known as the thermal bottleneck. Cummins is currently testing hydrogen engines to mitigate the risk of hydrogen embrittlement and erosion. Examples of hydrogen engines in the mobility and transportation sectors also go beyond medium and heavy-duty trucking. You can find users creating hydrogen engines in marine construction and beyond. Cummins has recently formed a joint venture with UPROXS, a leader in hydrogen storage and transportation for hydrogen storage tanks. With regard to transportation, there has been researching related to using ammonia borane, a hydrogen storage compound from which the hydrogen can be separated using a membrane. This offers transportation advantages as ammonia is easier to safely store in tankers than pure hydrogen. In addition to the fuel tanks of vehicles and transportation issues, the hydrogen needs to be stored at hydrogen filling stations. The low ignition energy coupled with hydrogen's high combustion energy and the fact that the gas tends to leak from the tanks has led to explosions at hydrogen filling stations. Again, this is an obvious factor that needs to be addressed ahead of the widespread use of hydrogen vehicles. FCEV models such as the Hyundai Nexo and Toyota Mirai have a WLTP range of more than 400 miles, and a Mirai recently covered 600 miles on a single tank. Even the longest range battery EVs can only manage around 300 miles, linked to quick refueling. This gives them an advantage over long-distance vehicles. Those backing hydrogen power also argue that fuel cells are better suited to heavier purposes, including industrial vehicles such as trains, ships, and potentially even planes, where batteries cannot produce the required power or longevity. The Stellaris Group recently announced plans for FCEV versions of its mid-sized cargo vans, including the Vauxhall Vivaro, to offer long-range and quick refueling to businesses in place of combustion engine or BEV models. Toyota builds the world's first megawatt-scale carbonate fuel cell power generation plant with a hydrogen fueling station. This trigen facility used locally sourced agriculture biowaste to generate huge amounts of power, lots of hydrogen, and clean water. Yes, that probably means cow poop. The plant generates approximately 2.5 megawatts of electricity, which is equivalent to the amount used by 2350 average's home in the region. Additionally, the plant produces 1.2 tons of hydrogen every day, which is enough to power about 1,500 vehicles on an average daily drive. The hydrogen generated on site is used in all Toyota fuel cell vehicles at the port, from Toyota Mirai fuel cell cars being delivered through the site to the Toyota Project Portal heavy-duty hydrogen fuel cell truck. Trigen is a major step forward for sustainable mobility and a key accomplishment of our 2050 environmental challenge to achieve net zero CO2 emissions from our operations, says Doug Murtha, Group VP of Strategic Planning at Toyota. Hydrogen cars are expensive to buy, and there are only two currently on sale. The Hyundai Nexo is around £70,000 and the Toyota Mirai costs £50,000. That, however, is £15,000 cheaper than the first generation Mirai and hints that costs could come down. It's also comparable to EVs from brands such as Audi, Tesla, and BMW. In the UK, hydrogen fuel costs between £10 and £15 per kg. It's measured in kilograms rather than liters. That means filling a Hyundai Nexo's 6.33 kilogram tank, which offers a claimed 414 miles of range, will cost anywhere between 63 and 95 pounds. With a consumption of 0.95 kilograms per 100 kilometers, 62 miles, that means it'll cost around 11.4 pounds to cover 100 kilometers at a cost of 12 pounds per kg. An equivalent diesel with an economy of 55 mpg, 5.1 liter per 100 kilometers, will cost around 6.76 pounds to cover the same distance. Petrol with an economy of 49 mpg, the UK new car average in 2019 cost 7.48 pounds. Now that we've come to the end of this video, I want to thank you for sticking with me, and I'd love to know what you think of it. Just comment down below. Also, if you like this video, make sure you like it and stay safe. This video is over, but if you want to see more, there's one on your screen right now, and there are a few more fun videos coming soon. I'll see you in the next video. Until then, take care, stay safe, and be happy.